Welcome to 7th grade math, Math 7, Chapter 5, Section 2, Simplifying Expressions. This begins on page 252 in your math book. Simplifying expressions. We are going to begin with some important terms for simplifying expressions. Be sure to pause the video when you need to take down some notes or try a sample, and you can come back and press play. As we look at this first expression, remember, it's called that because it does not have an equal sign, right? As we look at it, how many terms does this expression have? So I'm hoping that you can see there are like 1, 2, 3, 4 different things being added together. The definition of terms is parts of the expression being added together. So I see this subtraction sign. So we have learned this year that when you see subtraction, what do you change it to? That's right, addition of the opposite. So we could change the subtracting 4 to adding -4. So when we see subtraction, we'll do that. And so we have actually 4 different terms being added together. And we're going to list those terms for this example. So the first term is -x. Good. The second term is 3x. See if you can write down the others. And hopefully you have 2y and the final term, which is -4. Good. So terms are the part of the expression, the parts that are being added together. Our second concept of the day is coefficient. Coefficient. We've talked about this a little bit before this year, and hopefully you can remember that a coefficient is, let's take a look at this second term here. The second term has a 3 and an x. What's that operation taking place between that? Good, multiplication. So when you have a little term like that, 3x, we know that there's a sharing. Like co-captains of a soccer team, they share the job of captain, right? Well, a coefficient is a number that is sharing the term, sharing a variable. Okay, so the definition really is the number part of a term that has a variable part, like the 3 in 3x. Okay, so if we try to identify all of the coefficients in this expression here, what number is there in front of this x variable here? And hopefully you said -1. That's right, -1. So the invisible coefficient 1 is in front of that x. For the term 3x, the coefficient is 3. Good. For the term 2y, the coefficient is 2. And for the term -4, the coefficient is, there is no coefficient. Why is there no coefficient in the term -4? Well, that term does not have a variable, right? So a coefficient shares a number and a variable, and there is no variable there. It is not a coefficient, okay? Like terms. What do like terms have? Like terms have the same variable raised to the same power. So when we have like terms, we can combine them, and that's what we're going to do next. But as we look at this example again, which of the 4 terms are like terms? Which have the same variable to the same power? And I hope you see -x and 3x. Good. They are the only like terms in this expression. So we could combine them, and that's what we're going to do next. But before we do, we have one other concept, and that is constant terms. So when we think of the word constant, hopefully you think never changing. So something that's constant if you are a person who constantly talks, you're always talking. You are not changing. So constant is never changing. Let's see what the definition says. It's a number that never changes. It never varies because it has no variable. Just a number standing alone. So as we look at this expression, again, which term is just a number standing alone? And you got it, -4. So that -4 wasn't a coefficient, it is a constant. Okay? Okay, so now here is an opportunity for you to identify the parts of an expression. You're going to identify the same parts we just discussed. This is a new expression. Wow, it's pretty long. And so I want you to name all 4 of the terms that we just identified on the previous page. And then pause the video, come on back and see if you have the right answers. Okay, welcome back. The terms, we can see that there are 1, 2, 3, 4, and 5 terms, okay? And so, again, when you see subtraction, don't forget that we're adding all of these together. So this is not really -1, this is really -1, right? So some people need to change all of these subtraction operations to adding the opposite, which we can show like this. Okay, and some people can actually identify the -1 without going through that process. So when naming the terms, hopefully you started with 4x, -1, -4y, 8x, and y. Good. Now when we look for the coefficients, we have 4, there's no variable, so no coefficient there, -4, 8, and what is the invisible coefficient here? 1. Good. And like terms, we actually have, there's a x, 4x, right? And we have 8x's, so there are like terms. And we also have -4y and a +1y. Good. And constants, there's only one constant, a number that will always be itself, and that is -1. Very good. Okay, so we can now begin to combine like terms. Combining like terms. Let's try that with this. We have 6a plus 5a. There's a way we can expand 6a plus 5a, because what are both terms? Variables? A. So we have 6 times a plus 5 times a. We can expand that as 6 plus 5 times a. That's kind of reverse distributive property, isn't it? We're dividing the a out of each term. Here it is out here. Okay? So what we really want to do when we have like terms, they have the same variable, is add the coefficients. 6 plus 5 is 11a. Good. So this is using the distributive property, right? See if you can do that with this example. Again, we have like terms. They both have x to the first, right? So if you were going to expand it, you could say -10 plus 3 times x. Good. And when you simplify that parentheses, you end up with -7x. Let's try that with something a little more complex. Okay? Can you simplify this expression? Okay, so one thing we said when simplifying these expressions is we can change all of the subtraction to addition of the opposite, right? So when we do that, we're sure to carry our signs with us if we happen to move the terms, right? So that's our first little hint, is change your subtraction to addition of the opposite. Now we can move our like terms next to one another. Using which property of addition? Good, the commutative. So 17a would like to be closer to -4a, so we move that over. Good. 17a plus a -4a, close together, plus 3b, And I like to kind of check things off as we go. So I'll use, how about an orange pen? So we have 17a, we have negative 4, we have 3b plus a negative 1b. Notice I added the coefficient 1. Now when we look at the coefficients, we simply add the coefficients. 17 plus negative 4 is, good, 13a's, and 3b plus negative 1 is 2b's. Good. And so 13a's plus 2b's is 13a's plus 2b's. That's what it is. We don't say 15 anything. These are not like terms. So it is a common error for somebody to say that this is 15 ABs or something. And we don't say that because, look, they're not like terms. If I have 13 apples plus 2 bananas, I do not have 15 bananas. I have 13 apples and 2 bananas. They are separate things. Okay, so make sure you keep them separate if they do not have the same variable to the same degree. Okay, this is just a little bit more complicated, this expression here. We're going to simplify the expression, and there's a little more going on. So when you see parentheses like this and more than one operation, I hope you think of our favorite little phrase, and that is, hopefully you have it, PEMDAS. Good. So we have to make sure that we use the correct orders of operation when combining like terms, even in an expression that is not yet an equation. So the first thing PEMDAS asks us to do is address the grouping symbols. So when we look at this, D plus 3, can we add those two things? Are they like terms? No, they're not like terms. There's a 1D, and here we have 3. It has no D's, so we cannot combine them. The next thing we would do is exponents. I see none. Multiplication or division. So do you see the multiplication here? And what do we call that property that we use? That's right, distributive. We're going to multiply 5 times D. That gives us 5D. All right. And we're going to multiply 5 times 3. So 5D plus, what is 5 times 3? 15. Good. And, excuse my writing with this cursor. We talked about changing subtraction to addition of the opposite. So let's do that now. Good. So we have plus a negative 2D. Negative 2D. Okay, good. So now in order to finish simplifying, are there like terms? If there are, we can combine them. We have 5D plus a negative 2D. How many D's does that leave us? 3D. Okay, we have 3D plus, we have this one term that has no D's. What do we call that? A constant. Good. So it's 15 plus 15. Ta-da! 3D plus 15. So what is 3D plus 15? It's 3D plus 15. It is not 18 of anything, right? Because these are not like terms. That is our simplified expression. Okay, one tricky little sample for you. Try this out. Pause the video, try it out, and come back and see if you have the correct answer. Okay, now that you're back, don't forget we're going to change all of these subtraction to addition of the opposite, right? Addition of the opposite. So we have our correct signs. Now I'm just going to start distributing, right? What is 5 times x? 5x. Plus, what is 5 times 2? 10. Good. And then over here we have, next set, we have negative 5 times y. So I end up with negative 5y. Plus, we have the negative 5 times 3, which is negative 15. Good. And we've got to keep bringing everything down. Here we have our negative 2x. We bring that down. And we have, whoops, that's an x. We have our 5y. It's just sitting there alone. Okay. Good. We have a lot of terms in this expression, don't we? So now we start from the left. I have a 5x